Hi, today we're going to be talking about graphing quadratics as well as a little bit of transformations. So let's start out by looking at the transformation version of the quadratic equation. And here we go. The equation is f of x equals a times b times x minus h squared plus k. Now I know what all of you are thinking.
I feel like we've seen these before. Oh,
Who are
don't
you?
mind me. I'm gonna pop in every so often.
That is kind of odd. But yes, you should feel like you've seen these before because this is very similar to what we did when we talked about absolute value or even just transformations at the beginning. And just like with absolute value, each of the letters A, B, H, and K have a job. A is vertical stretches, compressions, or reflections, remembering that if it's greater than 1 or less than -1, it's a stretch. If it's in between 0 and 1 or 0 and -1, it's a compression. Reflection reflects on the x-axis, so it'll go from going upward to downward. B, on the other hand, is a horizontal stretch, compression, or reflection. Negative ends up meaning that it reflects on the y-axis, meaning it will end up having all the values on the left go to the right, and all the ones on the right go to the left. In this case, it's also horizontal stretching and compression, though, uses the reciprocal. So, for instance, if B is 5, it's actually compression by 1/5. And if B was 0.2, that would be actually a compression of 5. I mean, a stretch of 5. Now let's talk about H. H is a horizontal shift left or right, and it affects our x value. So we end up using the opposite though. So if I say plus 5, it's actually moving not 5 to the right, but 5 to the left. And if I say minus 2, that's 2 to the right. K does what you expect. If I say plus 5, it's up 5. If I say minus 2, it's down 2. So now we're going to describe each transformation. Here's our first equation. So what we first have to talk about is this minus 2. And minus 2, remember, doesn't go left like you would expect, but goes right. So right 2. Then plus 1 is up, so up 1. Now let's talk about another. F of x equals 1/3 of 2 times, well, you see it. We're going to talk about the 1/3 first. Remember, it's in between 0 and 1, which means it is a vertical compression of 1/3. That 2, on the other hand, is going to end up being the reciprocal, meaning it's also a horizontal compression of 1/2. The x plus 1 means that it's actually moving 1 to the left, and then the minus 3 means down 3. So now we're going to talk about how to graph transformations. So the first thing I need you to look at is this part right up here where it says x minus 4. That's going to go in this upper right area. So what I do is minus 4 actually means it's moving 4 to the right, so I would write x plus 4. Then we need to look at this part that says 1/3. That 1/3 is going to go into this section, along with if there was anything on this side, which there is not. So in this case, I replace x minus 4 squared with y, meaning 1/3 y. So now we're just going to plug in our values. X plus 4, so at -2, that's 2. At -1, it's 3. At 0, it's 4, 5, and then 6. So now we're going to plug in our values on y. On y, 4 times 1/3 is 4/3. 4 times 1 times 1/3 is 1/3, and 0 times 1/3 is 0. Now if you notice, 1 and 1 are both actually there. And that means that below, it's also 1/3. Now you might be wondering, why is this occurring? And the answer is, this right here is where our vertex is, meaning it's also our axis of symmetry. And that's the reason why. Meaning, by the way, our final line is going to be 4/3. Then we just graph our points, and there we are. That's our equation. Now let's try this one right here. So once again, we're going to take what's in the parentheses, and that's going to go right there. But remember, we have to find the reciprocal. So it stays negative, but 2 becomes 1/2 x. Now, half blank plus 3 becomes 1/2 y plus 3. Then we just plug in our values. Remember, negative of a negative is positive, so positive 1, positive 0.5, 0, negative 0.5, and negative 1. Now we just plug in our 4. Half of 4 is 2, plus 3 is 5, 3.5, and then 3. Noticing, by the way, how these end up being the same. Hey, look, we just graphed it. Hooray! We did such a good job. But you know, sometimes we aren't given a transformation. We're given an equation in standard form. So the question becomes, when we're given an equation in standard form, what do we do?
You could just put it in the calculator instead.
No, that would be cheating. And we can't,
Not
because
a cheetah. A normal house cat.
I didn't say cheetah. That would be cheating. That would make you a cheater, not a cheetah. So, in this case, what we actually have to do is we have to find our vertex first. And the way we do that, remember, is we first find our x value in our vertex by using negative b over 2a. In this case, a is 1 and b is 2. So when I plug those in, I get negative 1. Then I put the negative 1 back into the original equation, and I get 0. Now I'm going to go to 0 and 1. And on the other direction, to make sure that I'm going to have that wonderful symmetry, I'm going to go the same distance down. So instead of plus 1, it's minus 1 to negative 2 and then negative 3. Then I plug in my values. At 0, it becomes just 1, which means negative 2 is also 1. And at 1, when I plug it in, I get 4, which means negative 3 will also plug in and get 4. And I just graph. By the way, you can double check any of these and see that that is actually what's going on. Here's another equation. In this case, our b is negative 3, meaning we end up actually getting 3 divided by negative 2, or, well, negative 1.5, which seems kind of hard, so
We're at least going to let the calculator solve this one, right?
No, I'm sorry, we can't.
Then why do we even have them?
To taunt you. But in all seriousness, once we know that our x value is negative 1.5, we will use our calculators to plug it into the equation so that we find out that y is 5.25. Now, the thing is, I don't want to keep going up by whole numbers to negative 0.5 and positive 0.5. I'm instead going to go half a step, so to negative 1 to negative 2, and then go a whole number from there, so that we keep our same distance, but we have whole numbers again. When I plug in negative 1, I end up getting 5, which is also what I get when I plug in negative 2. When I plug in 0, I obviously get 3, because it cancels both of the x parts out. If I plug in negative 3, I would get the exact same numbers. There we go. That's our graph. So that wasn't so hard, was it?
Well, I guess this way makes sense, but it feels like it could be so much easier.
Yeah, but we're not using our calculator just to put it into a table. All right, so we have one more that we're going to try here. In this case, it's y equals 2x squared minus 4. Now notice we don't even have a b, which makes it really easy because it means the x value at the vertex has to be 0, which means the y value when I plug in 0 is negative 4. Then I'm just going to go up 1 and then to 2 and down 1 and down to negative 1 and negative 2. When I plug in 1, I get negative 2. When I plug in 2, I get 4. And there's our graph. And that's it.